Hello, my name is Sang Yi, and I will be doing question 23 to 27 of chapter 4. So, what do you notice about the size and shape of the two stick figures? Well, what I have here is that they have the same shapes. They have the circle, the lines, the lines, the lines. And if we did the measurements, for example, AB, 4/6, and AB, they have the same measurements, but what's different is that it's flipped. So, or in the opposite direction. So for example, that line AB is on the left side, while line BA is on the right side. That has the same measurements. Same thing that goes with line BC and prime or transformed BC, first transformation. Okay, drag a point on the leg of the original stick figure, what happens, why, and then drag other points of the pre-image or the image stick figure. So if I were to drag this point, as we can see here, the arm on the left side would move, but the arm on the right side would move. Why is that? Well, this is the function of a flipped, or this is the function of a flip or a reflection. This is the function of reflection. It's a reflection of each other, which is like a mirror, and that's why reflection means like the opposite, basically, and that's why line AB and then line BA of the transformed part would move, like so, like this. All right, on to the question 25. Predict what will happen if you drag an endpoint of the mirror line segment. What happens? Well, let's say this is line segment A. If I were to move this, the right arm of the mirror image, then the left arm of the mirror image, then the right arm of the original image would move. See? Same thing that would happen. Same thing with this. Oh, woo. Sorry, that hurts. Anywho, but yeah, that's the reason why it would move. And because of the point is also connected to the other arm, that whole thing would move too. This is the whole point of reflection, because they're opposites. And predict what will happen if you drag point B right here, as we talked about it. Point B would also move, but also changing the properties of the lines and also the measurements, because there's new elements that are happening, aka if it goes down 1 unit, then that obviously, or 1 centimeters, then that means the distance would also change, but not just by 1 unit, no, by 1 centimeters. It's changed by a few more centimeters. It depends. We have to do an equation for that. So 27, create a segment joining the hand and the two stick position below. What do you notice about the segment and the line of reflection? Well, I have already created it, and if we have, oops, my bad, my mistake. If we were to draw a line, then the line would have equal distance from each other. Same thing with this. If we were to create a line, it would have the same distance as each other. So if we were to do this distance, measure distance, all right, and then measure this distance, they're all different. As you can see here, it's not the same thing as the translation where we set up a fixed distance of 5 centimeters. It's different. Depending on the position of where the point is, and depending on the position of the mirror this mirror right here, will depend on where the reflection would be too. Because it's supposed to be the complete opposite of the original image. So this is our fixed distance, or fixed, let's say, midline. This is the mirror, right? This line right here is the mirror. And we know from the mirror to the original image, the distance is 4.02 centimeters. So that means that for the mirror image, this point, the new transformation point, will also have to be 4.02 centimeters away from the mirror. And that is all. Thank you.